Krista Phelps. I work for the Indiana Department of Transportation. I'm a geologist out of the Division of Materials and Tests. And I'm going to present Highway Construction Materials in Indiana, Module 2A. So for this module, we're going to be talking about the aggregate side of the asphalt mixture. Asphalt is a mixture of binder and aggregate, so we're going to look at the aggregates. So yay, because I'm a geologist and geologists like rocks. We're going to take a look at the aggregate types and their origin and how they're distributed in Indiana, because that has an effect on the geology has an effect on where the aggregates come from in the state. And materials found in Indiana, aggregates which are considered non-durable as well, or deleterious. So there are 4 aggregate types that may be found in Indiana. We have sand and gravel. We have crushed stone, and then also slag materials. And each of these aggregate types have their own unique origin. So natural sand and gravel used in asphalt pavements is transported several different ways. It can be transported it was transported in Indiana by glaciers, and then it still is today transported by streams. It's exceedingly abundant in this state. We're going to take a look at why. So thousands of years ago, or even millions of years ago, there were glaciers in Indiana that transported materials from Canada. And you can see in the graphic on the left, you've got the Great Lakes to the north, and you can see those arrows, and then you can see the ice sheets, the movement of the ice sheets. If you look at the border of Indiana, you can see that it came way down into our state. It's hard to imagine now that some huge ice sheet would move across that much of the land surface of our state. But at some point, that was the case. For many years, that was the case. And so when those ice sheets moved across our state, they brought a lot of material down from Canada from various sources. So you can see a lot of different rock types in the sand and gravel deposits in Indiana. Especially prevalent to the northern part of our state, but even farther south you can find them too. And then you can find some that were transported by streams as well. So yeah, over the past 2.6 million years, there's been a series of glacial advances and retreats across the state, and you can see that those 2 lines, those are the major glacial advances in Indiana, and you can see that the light blue line goes pretty far south, and then that darker blue line is the one that probably the bulk of the material was from that advance. And it's interesting when you look at that graphic to the left that shows how the glacier moves. When you get to the end of it, you end up with a big hill. And I don't know how many of you have noticed this, but when you're going down into Martinsville, down 37, there's a huge hill down 37, and that's what that is. That's, if you look at where that line is, that's the end of a glacier basically that caused that. There's many glacial features in Indiana like that, but that's one that kind of, I guess, maybe a lot of people would be familiar with. And so, yeah, beyond the glaciers, streams carry sand and gravel. So another word that you might run into is fluvial. And the larger the river, the more material it's able to move. And we have multiple large rivers in Indiana. We've got the Ohio to our southern border. We've got the White River that kind of splits and branches through the middle of the state. And then we've also got the Wabash River to the west. So there are 3 rock types, and this shows the rock cycle. And sedimentary rocks is really what we see in our bedrock in Indiana. And I'm going to show you a little bit more about why that is, but there's also igneous and metamorphic rocks here, and the reason why is because, we got all those rocks from Canada, so, there's the setting to produce igneous and metamorphic rocks was present at some point in different parts of Canada, and, the glaciers moved the rock here. So in our sand and gravel, we see all different rock types. In our bedrock units, we actually just see sedimentary rock. And then the type of road aggregate used in the United States is dependent on, the geology for that area, because transportation is expensive. So, in Indiana, what we see in our roads is just a product of what we have in our geology in our state. So, we have a lot of limestone in our roads in certain parts of the state, and then we have areas that are, have a lot of sand and gravel in them too. And so, yeah, we have ocean marine fossils in our Indiana bedrock in the southern part of the state. And, how is that possible? Because, how do we have ocean marine fossils? We're in the middle of the continent. We don't have an ocean anywhere around us right now. So somehow those ended up in the bedrock in our state. And so this shows you kind of, I guess, how that happened. When you go down far enough to go back 458 million years, as this graphic shows, this is what the world map looked like at that time. And so if you look where it says Laurentia, that's a name given for, what the North American continent looked like at that time. And that line going through the middle of it is the equator. So, in other words, if you live and own property in Indiana now, you could have had oceanfront property 458 million years ago. But, that's not really the case now, because there's something called plate tectonics, and the lithospheric plates of the Earth move over time very slowly. And so the North American plate is not actually located there now. It would be similar to the climate, in the Bahamas, modern day. But that's why we have ocean marine fossils from a warm, shallow marine environment in our bedrock, because at some point we did have that type of environment here. Yeah, so this kind of shows too, everybody's kind of interested in Pangea, but I like this little graphic that shows the continents coming apart, because, they merged together and then they came back apart, through millions of years, hundreds of millions of years. And so that had an effect on, it even has an effect on us, that happened, because when the continents came together, they formed a tiny little mountain range called the Appalachian Mountains. And, when they formed, they weren't tiny at all. Actually, when you have two continental plates that collide together, they form really big mountain ranges. So the Appalachian Mountains were really high mountains at the time. It'd be, Mount Everest is part of a continental collision. So they were really tall mountains. But then over time, we had kind of water flowing. You can see here we have some ocean basins flowing in between land surface. And so over time, those mountains eroded, and then that material from the erosion collected in those basins. So in Indiana, we had a lot of sediment supply, and then over time that solidified and became rock. And so that's where we get our limestone, down in the bedrock. Hundreds of millions of years ago, a land surface eroded and sediments collected, and then over time it became the rock we use to build our roads today. And so, in terms of geologic structures, you know, you don't need to know a lot about this, but it's just kind of interesting, I think, that you have the Kankakee Arch and the Cincinnati Arch that come across the state. And, this is just a look at Indiana. It goes actually down into Ohio and Illinois as well. Um, and, because of that arch, it kind of, the um, sedimentary structures were kind of pushed up a little bit, and then there's a 5-degree tilt uh, in our bedrock in Indiana that tilts down towards the Illinois basin. Um, but for the most part, when you look at the rock in Indiana, when you're looking at a road cut or when you're looking at a quarry high wall, what you're seeing is layer cake geology. It's relatively, it has that little 5-degree tilt, but it's not much at all. It's, for the most part, it's, pretty flat sedimentary features. So this shows the strat column. Again, you're not going to need to know this type of thing, but when geologists go out to a quarry and they look at the stratigraphy there, they kind of know where things correlate in the rock record, and they kind of know what to expect to find. We know if we're going to see shale, we know if we're going to see chert. When it comes to our department, we know certain things about the physical characteristics of the rock based on where it is in the strat column. So at any rate, this kind of gives you an idea, I guess, of how that lines up. So we also talked about the fact that there's slag in Indiana. So slag is a byproduct of steel manufacturing. So we have slag suppliers along the northern border near Lake Michigan, where the steel mills are, and then also there are some slag producers along the southern border as well. And so it's kind of, again, a regional thing where you see slag materials in certain areas. Slag is a good material for asphalt, sometimes because of its frictional properties. So again, the differences in geology in Indiana create this difference in physical properties and difference in areas where you'll find this material throughout the state. So then that basically dictates where you find locations that have certain products. So in the northern part of the state, there is a lot of sand and gravel because of the glaciers. So you're going to see a lot of, on here it's depicted in green. You see a lot of sand and gravel locations. And then if you also notice, if you know where the streams are in Indiana, you can see that those green dots follow along the White River, and they follow along the southern border along the Ohio, and they follow along the western border along the Wabash River. And then you also see that there is a bit of a pattern to where you see crushed stone locations. So those pink dots, a lot of them are in southern Indiana. It's easier to get to the bedrock there because there's not as much glacial material on top of it. And you also see that there's, a certain pattern to it because those pink dots that come down in a line, that's all Mississippian limestone, which is world-renowned limestone. And so you see a lot of quarries along there. And then also you can see those slag producers in yellow along the northern border along Lake Michigan where the steel mills are. So, it has our geology has a lot to do with where our road making materials come from in the state. So this shows how a shot is put down in a stone quarry. So, if you weren't awake, hopefully that woke you up. And, once the shot is put down, then, you see the haul truck down there at the bottom that's getting loaded. And then it's hauled and then it's taken to a different part of the quarry for crushing. Um, Here you see some natural sand and gravel operations. So you've got, you know, uh, streams that, where there's sandbars and gravel banks, and then, also dredging operations. And then down there to the lower right, you have like a gravel bank. Looks like maybe a glacial feature. And then dredging operation on the Ohio River along the southern border. What we have here is a jaw crusher. So you saw that haul truck earlier. So it would take the material to the primary crusher and run it through and break it into smaller pieces. And then you're going to see here in a minute, there's a conveyor belt that takes it to the plant. So you got smaller material going up and then over to the plant for further processing. So the stone is processed by crushing, screening, and washing to produce the size and angularity that we want that's optimal for road making. I always think this looks like a roller coaster at Kings Island. When I look over across the quarry, it has all this different, yeah, anyway. And so screening is a good technique for gradation control. And gradation is, the product has to meet state spec. And then it's also important, in terms of consistency in your asphalt. So also in Indiana, we have materials that are considered non-durable. Not every rock is good for road making. And so these are some examples of things that you might find in a sample that, has properties that are not optimal for road making. So we have a conglomerate here. Basically, it's just a mix of different rocks that's cemented together. Kind of looks like a concrete or something, but it's a natural rock. And so, as you can imagine, these larger particles are held together kind of loosely, and they can break apart pretty easy. So that can cause a problem for your mixtures. And we also have sandstone. We do have a few sandstones that come from southern Illinois that are, actually have properties that we like, that, they're pretty skid resistant materials. But for the most part, sandstone is not a very good material for road making. It has a lot of feldspar in it, and the feldspars tend to weather out, and so it can kind of tend to come apart. And so it looks a lot like limestone, but the way you can tell them apart is if you put a weak acid on limestone, it'll fizz. The calcium carbonate, tends to react with the acid to make a gas. And but anyway, that's kind of how you can tell them apart. And we also have shales in Indiana. Shales are not optimal, and this is kind of what it looks like. It's a fine grain, thinly laminated, and those sheets, you can see those sheets can break apart, and it's just not good to have this in your aggregate in terms of road making materials. And then limonite. So limonite is found in glacial materials many times, and it's that yellow brown soft rock, and it easily breaks apart. So it's it's not a good material. And then also weathered schist. So schist is a pretty tough rock, as it sits, but then again it's subject to weathering as well, and when it does weather, then it just kind of crumbles. So ochre is another one that's an iron oxide based rock that's kind of yellowish and tends to break apart really easily. And then another thing we might see in Indiana in the streams, and that that's where we get our materials, is just shells that are from modern mussels and things that live in the rivers. So those are not desirable either. So this is not to be confused with fossilized shells that are found in limestone, but yeah, unfossilized shells are not good to have in the aggregate. So, and that concludes this module, and stay tuned and we'll move on to module M2B.